Alright, now we are starting a new conversation. This one is generally under the umbrella of having some kind of a substitution. But in fact, I'm going to cover three separate ways, not related to one another, to solve differential equations. Okay. The first one will be related to the homogeneous function. But right there and then, I want to take a step and discuss what homogeneous equation for a linear differential equation was. So what we said was, if we have a linear first order ODE, and it's given by this, you may remember this, a1 y prime plus a0 y is equal to g sub of x. And if we said that if this is equal to 0, so the right hand side is equal to 0, then what I will get myself is, this is called a homogeneous linear first order differential equation. Okay, so I'm not talking about that one over here though. Just want to clarify that this is not what I'm talking about. This is still valid, but I'm talking about a homogeneous function. So what homogeneous function? Let's go ahead and write that. Homogeneous function, here's what it is. I look at the highest exponent on both in terms of x and y. Obviously, I'm assuming x is the independent variable, y is the dependent variable, right? And if I can factor those out completely, that's what it means that this is a homogeneous function. So I'm looking at the highest exponent of each x and y, so they need to be the same, right? So I think it's much easier. I don't want to write the definition, but it's much easier to illustrate this with the, let's say that I have a differential form given. I'm going to use the differential form. The reason is, in the last set of modules we focused on it, so it's kind of fresh. Everybody remembers this, and we can call this fx, y. This function is homogeneous, and the way that I can understand whether it's homogeneous or not is, instead of writing an x, I go ahead and insert t sub times x. Okay, and I do the same thing for y, t times y. Then what happens in here is, if I have m tx, ty will be, if this is t to the power of alpha, that is the highest order, m x, y, and if I have the same for n, tx, ty will be equal to t to the alpha. Note that this is the same. This is important. N x, y. If this happens, so if these alphas are the same, it doesn't have to be. If one can be fifth order, the other one can be seventh order, right? But I'm saying that they are the same. If they are the same, this is called a homogeneous function, right? This particular function that I'm dealing with will be a homogeneous function. The approach here will be this, okay? You can do either of them. That's your choice. V times y, all right? So x is equal to v times y, or I do y is equal to u times x. Obviously, you can do either one of them, right? Because, v and u are arbitrary, so you can relate those two from these two equations, right? So if I go ahead and make this substitution, as the title of this particular set of segments state, what I will do is I will get myself a separable equation, all right? But I want to warn you, in general cases, even though the equation looks easy, the separable equation that you're going to get will look fairly complicated. Mathematics-wise, this particular approach, the homogeneous function one, is kind of dense. Okay, I want to make sure everybody understands that it's much more like a level or two above the separable equations that we discussed before. Okay, I'm still not 100% satisfied whether I was able to cover this, whether something is a homogeneous function or not. Okay, so I want to give you some examples without solving them, just to have some sense. Let's say that my m x, y is, I don't know, x to the power of 4 plus y to the power of 4. So is this a homogeneous function? Okay, so then I will apply the way that we define this. So I'm going to have tx, ty. So wherever I see x, I'm going to write tx to the power of 4 plus ty to the power of 4. So you can see over here, I get myself t to the 4 parentheses of x to the power of 4 plus y to the power of 4, right? So then you can see I was able to factor this out. So because each of them has an order of 4, fourth order. So this is a homogeneous function. So this is a homogeneous function, right? So this is fine. Let me give another example and see where it's going to take us. M x, y. And I'm going to give you a kind of tricky one because I see sometimes students use substitution for this in the exams. So what about this? Is this a homogeneous function or not? And sometimes, like I said, students say that this is a homogeneous function. Indeed, it's not. I'll show you. Okay. And if we do the same approach that we have done in the you know, up there, ty will be equal to tx to the power of 4 plus ty to the power of 4 minus tx, right? So you can see the first two, I have t to the power of x to the power of 4 plus y to the power of 4 and minus tx. So can I factor out this t outside of that? So I can write t to the power of something times x to the power of 4 plus y to the power of 4 minus x, because that's what this function is, right? So I cannot achieve that, okay? So for this reason, this is not a homogeneous function. So you cannot solve this particular equation by making this substitution, this or that. So, but for this case, if this was your mx comma y, then you can do the substitution and go ahead with that. Obviously, I have to have the same thing with n. I just did the half of it, right? So I have this one, and I also need to have that one, right? All right, so I want to go ahead and solve this particular question. Well, let's see whether this is exact or not from the previous segment. So this is this is called m. If you remember, this is called n. Del m del y will be 0. Del n del x will not be 0. So this is not exact as an example, right? But let's also check whether this is a homogeneous function or not, right? So the m that I'm given to myself looks like this, fairly easy. What about n? N is given as y minus 2x. So I'm gonna have this as tx, right? So you can see it's just the first. How about this? Ty minus 2tx. So I can have the t outside at y minus 2x. So this is n, this is m. So I got myself t times m for m, and the other one t times n. So these are the same order, right? So then this is good. So I should be able to have a homogeneous function, and I should be able to solve this. Both are homogeneous functions of power of 1, okay? So I will use what I said. Let's go up there and I can tell you what I mean. So you can do this or you can do that. Just to note that either one will be fine. You don't have to be using this or that, okay? Now, x is equal to vy, right? So let's do the substitution. And I'm looking up there. So wherever I see x, I write vy. So nothing too complicated so far. dvy, this is m, right? You know, that's what I'm writing up there. So the y minus 2vy dy is equal to 0. Okay, so let's do this. Vy times the chain rule that we can apply here, right? Y dy dv, sorry, plus v dy plus y dy minus 2vy is equal to 0. So let me kind of write the first parenthesis, so see whether there's any vy squared dv plus v squared y dy plus y dy minus 2vy dy is equal to 0. I see every term is multiplied by y, right? So I can divide both sides of the equation by y, so I can delete these y for each and every term. Vy dv, okay, plus. Now I am writing, with dv, and now I'm going to write the rest of them with respect to dy, right? It's a very standard form, almost like a mn kind of thing, right? So it's going to be v squared minus 2v. You can see why I changed the order of those in a minute if you haven't already, okay? So what is this? V minus 1 squared, right? Wonderful. So then I get myself vy dv plus v minus 1 squared dy is equal to 0. So let's write this. Divide both sides. The right hand side is obviously 0, doesn't really matter, but let's be consistent in case it is non-zero. V minus 1 squared. Okay. So why am I doing this? Because I want to get rid of y over here for separation purposes, right? I want to have v times dv. And why I'm dividing v minus 1 squared is because I want to get rid of that, so I can get something just with dy. So I can move everything with the v to the one side, everything y to the other side, and take integral of both sides. That's the ultimate goal I'm trying to achieve. Okay, so it's going to be v dv by v minus 1 squared plus dy by 1, y, will be equal to 0. So this term only has v, this term only has y. So now I can move one to the other side, so let's write it this way. V dv divided by v minus 1 squared is equal to minus dy by y. The next step is obviously to take the integral of both sides and see what happens. I have one particular principle that we discussed is wonderful for these kind of cases. It's called integration by parts. Okay, so do not write here u, v, vu. So I'm going to change the variables. So I'm going to call this tdr is equal to rt minus rdt. Okay, so I'm just change u to t, v to drs because I'm using v in the equation itself for separation of variables. So from here I'm going to use t is equal to v because I can take the derivative of that easily. So it's going to be dt is equal to dv. How about then dr? So that will be dv by v minus 1 squared. R is equal to minus 1 times, right, v minus 1 to the power of minus 1, right? Then I will just simply plug that into the equation that I see. So it's going to be this one will be minus v by v minus 1. I just wanted to write this way. You can write v to the minus 1 to the power of minus 1 if you choose to do that. Minus, but then it becomes plus because I have a minus here. So it's going to plus dv by v minus 1. So okay, the first term I don't think I can do much with it. v divided by v minus 1 plus. So what is this? ln v minus 1, right? Let's say v minus 1 is equal to a. So it's going to be dA by a. And the integral of that is, the natural logarithm of that particular variable that I selected. Okay, so I was able to obtain the left hand side. How about the right hand side? I didn't do it yet, but you can see that I'm going to get myself a minus ln of y. So this was easy, right? So then if I combine these things, here's what's going to look. Minus v divided by v minus 1. I told you this is going to be a bit dense, right? And it already is. And the equation itself was the power is first order, right? Plus ln of y is equal to c. Obviously, I failed to write it in here, but there's a integration constant of plus c there. Rewrites it this way: v is equal to x by y, right? So now I'm going to go down there and I'm going to write wherever I see v, I'm going to write x by y, right? So then let's do one time. Minus x by y divided by x by y minus 1 plus ln x by y minus 1 plus, well, do you see, instead of can I write this way? Is equal to c. So let's look at this first term. If I do like over 1, if I multiply by 1, so I'm going to get myself, let's go to the next page. I will get myself minus x, y's will cancel, divided by x minus y. See whether it makes sense to you. And so from here, it's going to be ln of, well, if I multiply that, so that's going to be x, y, y's cancel. So I got myself x minus y is equal to c. And then I can do the same thing I did up. So I have to multiply this by x minus y. And I get myself x minus y ln x minus y minus x, right, is equal to c x minus y. So then I can do maybe one more step. Ln x minus y to the power of x minus y minus x is equal to c x minus y. I think I'm going to stop here. I have worked with it enough. Okay, let's go ahead and solve the initial value problem. The first thing I'm going to do is, let's see whether that's a separable equation by itself. No, not really. The second thing is I have to check whether this is linear. I think that needs a moment from my side. dy dx, if I divide x divided by what dy dx, y cubed, the second term is linear, but the right hand side is not linear, so this is not linear. The third thing is, let's see whether this is exact. So let's call this actually, why don't we do m and n? We will check it anyways. So let's do this. X comma y is equal to, let's say, y cubed minus x cubed, and n is negative. Why do I have a negative? Is I have to have m dx plus n dy. So one of them needs to be negative. So I pick this. So you can see del m del y will be 3y squared. Del n del x will be minus y squared. So they're not the same. So this is not exact. So you may try to do integration factor for exact and try to see whether you can obtain something exact. Okay. But now what I'm going to do is I'm going to try to do this from the approach that we just established in this particular set of videos that we are covering. So why don't I do this? M tx comma ty. That will be t cubed. I'm not showing the details because I did the exact same thing in the previous video. Okay. And this is my m x comma y, right? So let's see the same thing for n, tx, ty, and you will see that I will get myself t to the power of 3 times minus xy squared. Obviously this is n, x comma y. So you can see that the power, it was alpha, so now this alpha is 3 for both of them. So this particular function I'm looking at is a homogeneous function. So I should be able to do this. Do you remember in the previous segment, what I did was I said x is equal to v times y, right? And I said also we have this y is equal to ux. That's just the reverse of it, right? So as I practiced this in the previous segment, why don't I practice this in this particular segment? But the final answer should be the same regardless of which one you pick, okay? But I'm gonna just go ahead and select this one, y is equal to ux. Okay, let's put up there into the original equation. So x, wherever I see y, I put ux square d ux dx will be equal to ux cube, which is y cube, minus x cube. Okay, so then let's do one more step, x cube u square, right, times chain rule, u dx by dx, right, plus x du by dx is equal to u cube x cube minus x cube. Well, this is 1, right? You see that becomes 1. You see each term is multiplied by x cube, right? Why don't I go ahead and divide each side of the equation by x cube so I get something a little bit more manageable. So let's write to this side. So u square u plus x du dx is equal to u cube minus 1. Just want to highlight in here, sometimes I see this in the students' exams when I'm grading. So make sure that you're not left with any y term over here, right? Because you did the substitution, I should get rid of the y. If you see a y, you didn't do a proper substitution. Just want to highlight. Okay, do you see this? These terms cancel because u cube on the left hand side, u cube on the right hand side. Okay, then I get, you know, u square x du dx is equal to minus 1, right? Okay, can I do separation of variables? This looks a little bit easier than what I did before. I can do this. U squared du is equal to minus dx by x, right? So then I'm going to do the integration. The left hand side will be u cubed by 3, right? Will be equal to minus ln of x plus a constant of, let's call this c. Let's do one more step over here so I can do this. Multiply each side by 3. So I got myself u cube is equal to minus ln x cube, right? Plus, I'm going to call this, I don't know, d, where d is equal to 3 times c, arbitrary constant, right? And then at this point, then I'm going to go back and insert what my u was. Actually, if I go up here, you can see that my u is equal to y by x, right? So I will write that. So that's going to be y by x, that's right here, to the power of 3 will be equal to minus ln, if you want, you can put this minus to the top. I don't need to. X cube plus a d. Let me actually find out what this d is. Okay, why am I doing that? Because I'm asking for the particular solution. And if I go up here into the question itself, you can see that this is y1 is equal to 2. So x is equal to 1 and y is equal to 2. So let's insert it into my calculation. So I'm going to get 2 to the power of 3, right? So that's going to be 8 will be equal to minus ln of 1, right, plus d, right? So from here you can see that I get myself d is equal to 8. Obviously ln 1 is 0. Y by x cube is equal to minus ln x cube plus 8. D is 8, right? So then I can do one last step if I choose to. So I can have y cube is equal to minus x cube ln x cube plus 8x cube. I think that's gonna do it for me for this particular segment. Thank you for watching this. I'll catch up with you in the next one. Thanks.